Hi all, so now we are going to do the same example on inverse probabilities that are non-standard normal distributions. So we're working with the same example. Supposing a certain car prices follow a normal distribution with a mean of 40,000 and a standard deviation of 5,000. So for the first part, we're looking to find the 65th percentile. If you recall what that means, it's the prices that are above 65% of all of the cars. So I wrote out both the formulas. So z equals x minus mu over sigma can be written and rearranged to x equals z times sigma plus mu. So for the first thing I want to do is sketch a graph for the first part. I want to sketch a graph over here of just draw the curve, and I want to show that 65% is above. So here is 65. So this area is 0.65. And I'm drawing this over here because I don't want to draw it here because we don't know where the 65% is sketched, where this line goes. So we're looking for the 65% to the left in this case. If you recall from the previous lecture, we go over to the normal table and we look for the closest value to 65%, 0.65, in the middle of the table. So let's go over to the table. It's going to be positive because it's above. So we look for what's closest to 65. So these two values look like they're close to 0.65 and they're both evenly. So I'm going to use 0.385 because 0.08 and 0.9 halfway is 0.085. So 0.385 in this example. So drawing that on this graph, we have 0.385. And now we know where to draw that on this graph because we have this is a z-score, a z-value. So it's going to be around, let's just approximate it right here. Not too bad. Okay, so this is a z-score, a z-value. .385. So now we have the z, and we want to convert it to x using one of the two formulas. I'm going to start with the first one. So we have our z is 0.385 equals, we don't know the x, so we keep that as x, minus mu, which is our mean, so 40, over sigma, so sigma is, our standard deviation is 5. So to get that to x, we just times, so x equals 0.385 times 5, so 0.385 times 5, and then plus 40. And if we calculate that out, we're going to get 41.925. And I want to check if that makes sense on this plot. So we're going to just put 41.9. So if we shade this in. So yes, this makes sense. That and it's saying that 65% of all the cars would be below $41.925 thousand. So the second example, we want to find two values that make up the middle 95% of all cars of this brand. So we start again. Let's just draw another plot. And we want to find the middle 95%. So if we have 95% in the middle, that means that we have 0.05 in the tails. And that means that 0.05 divided by 2, it gives us 0.025 in each tail, because this is both tails combined, so we have 0.025 here and 0.025 here. Okay, so if we look that up in the table, so if we look up 0.025 in the table, it's going to be negative. A value that's closest to 0.025 in the middle. Oh, right on. Okay, so we get negative 1.96. So we can, so that's going to be negative 1.96. And the reciprocal of that is just 1.96. So now we can draw this on the graph, because we know where that is. So that's going to be right here. So that's a z, negative 1, and again. Positive. And we want to find the middle 95%. And that's the 95%. Okay, so now we want to find the x's. So we need to convert again the z's to x's. So we're going to switch and do x equals negative, let's do the negative side first, 1.96 times the standard deviation, which is 5, plus the mean, which is 40. And if you do that out on your calculator, you will get 30.2. And then for the positive side, we have 1.96 instead. Times 5 plus 40. And we get 49.8. So checking if this makes sense on the plot, we have 30.2, and indeed that makes sense. And then we have 49.8, which is, it looks like the line is very close to 50, so yes, this makes sense. So this just means that 95% of all the car prices would be between these two values. And that's it for these examples. Continue on to the next task.